Welcome back. This is also, like the previous videos, almost a revision of grade 11. So let's finish up this, and after this video we'll jump into grade 12 stuff. We used these three equations in grade 11 to find the nth term, or the general formula, or the general term that is a specific equation for any given sequence. For linear we use this, for quadratic we use this, for geometric we use this. So let us quickly recap using examples. Let us start with linear. Consider the following pattern: 4, 9, 14. Determine the expression of the nth term of the pattern. Determine if 1099 is a term of the number pattern. So basically what they are asking you is find a specific equation that can help us to find any term. This is what they are asking. Then test that equation to see if any number given or any position given is part of the equation. Okay, so let's start. So we begin by writing our number pattern: 4, 9, 14. The first step is always to look for the common difference: 9 minus 4, 5, 14 minus 9, 5. So we have D is equals to 5. The first term, we call it A, is 4. Now, for linear patterns, we use Tn is equals to A plus n minus 1 times D. Then you substitute these values. Tn is equals to 4 plus n minus 1. D is 5. So Tn is equals to 4 plus 5n minus 5. And Tn is equals to 4 minus 5, that's minus 1. 5n minus 1. So this is the general equation. So we can use this to find any term in this number pattern. Determine if 1099 is a term of the number pattern. N is the position, Tn is the number in that position, or the term in that position. So 1099 is a term so 1099 plus 1, we are looking for n. So since n is a positive integer, we know that 1099 is part of the sequence. Example 2, given the sequence 10741, determine the formula for the nth term of the sequence. Then part B, which term of the sequence is equal to minus 179. You write down your sequence first, then find the common difference. 7 minus 10, get a minus 3. 4 minus 7 minus 3, 1 minus 4 minus 3. So your D is minus 3. The first term, A, is equals to 10. So for linear, we get our general equation from writing this formula, then we substitute. Tn, A is 10 plus n minus 1, D is minus 3. Let's simplify. Tn is equals to 13 minus 3n. So this is a general formula which will help us to find any term in this number pattern. Part B, which term of the sequence is equal to minus 179? So we are given a number Tn equals to minus 179. We want to find the n. Which term is that? Is it the first, the second, the third term, or the fourth term? So let's do that. Tn is equals to 13 minus 3n. We want to find the n. So let's substitute there. Minus 179. 13 minus 3n. Let's put 3n this side. It becomes positive. Let's put minus 179 that side. It becomes positive as well. N is equal to 64. So you can write T64 is equals to minus 179. That's the answer. Or you can actually write in words. Term number 64 has the value of minus 179. Consider the following quadratic number pattern 1618. Part A, write down the next two terms. Usually for quadratic, you need more than 3 terms for you to be able to find the first and the second difference. Part B, determine the equation of the general term in the form Tn is equals to an squared plus bn plus c. So after getting the equation, they now ask you to use the equation, calculate the value of T12. This is another way of saying find the value of the 12th term. Write down the next two terms. So always find the common difference first. 10 minus 6, get a 4. 18 minus 10, that's an 8. Now, because we don't know what's there, let's just put a blank, and also let's put a blank here. Let's write the second difference. 8 minus 4, that's a 4. Since this is a quadratic, we know that on D2, that's where our common difference is, so everything here is 4. Okay, now let us calculate these two. 4 plus 4, you get an 8. 8 plus 4, this is a 12. 12 plus 4, this is a 16. Now let's calculate these two. 6 plus 4, you get a 10. 10 plus 8, you get an 18. 18 plus 12, you get 30. 30 plus 16, you get 46. So part A, you write the next two terms are, this is the sequence, and these are the next two terms, 30 and 46. So usually in your exams, it's a mark for a minute. So if they say 3 marks, you're expected to do 3 minutes on that question. And you will have 30 extra minutes to 45 extra minutes if you follow that pattern. Determine the equation of the general term. So for quadratic number patterns, we use this formula to determine the specific equation which we want. So you just need to find A, B, and C. This is how we do it. Come here, write 2A. Come on this line, we write 3A plus B. on this line a plus b plus c. So we will start here going up, okay, and you will be only using this. Let us start. 2a is equal to 4. A is equals to 4 over 2. A is equals to 2. We now have our A. Let's do this one. 3a plus b is equal to 4. We have A, it's 2. B is equals to minus 2. A plus B plus C is equal to 6. A plus B plus C is equal to 6. A is 2. B is minus 2. Plus C is equal to 6. 2 minus 2, that is 0. So we're left with C is equal to 6. So we now have A, B, and C. We substitute into that. So we have Tn is equal to 2 for A, n squared, B is minus 2, C is 6. So that's the equation which they are looking for. Calculate the value of T12. This means calculate the 12th term. N is equals to 12. With n equals to 12, T12 is equals to 2 times 12 squared minus 2 times 12 plus 6. You can put that in your calculator. T12 is equals to 270. So the 12th term is 270. Example 2 on quadratic number patterns. Given the following quadratic sequence 0, p, 2, and 6, calculate the value of p, then determine the expression of the nth term of this sequence. Now, because it's a quadratic, we know that we are going to have two differences, d1 and d2. So let us start. P minus 0, you are left with p. 2 minus p is 2 minus p. 6 minus 2, get a 4. That's the first difference. Let's do the second difference. 2 minus p minus p. 2 minus p minus p. This is what goes here. Next one, 4 minus this. 4 minus 2 minus p. This is the second difference. Now, in quadratic number patterns, we know that this is the common d. These are the same, they are equal. Therefore, we can write 2 minus p is equal to 4 minus 2 minus p. Now let us put all the p's to one side and the 2's to one side. 2 minus 2 is equal to p plus 2p. 3p is equal to 0. So p is equal to 0. Now, after finding the value of p, they are saying determine the expression of the nth term. Now, if you recall, you said you come to the second difference and you write 2a. The first difference you write 3a, then you say plus b. On the sequence you write a plus b plus c. Then we said you only use the first line. So let's start. 2a is equals to 2 minus p minus p. 2a is equals to 2 minus 0 minus 0. 2a is equals to 2. A equals to 1. We've managed to find a. Let's go to this one. 3a plus b is equal to p. Let's calculate. We know that a is equals to 1. So 3 times 1 plus b is equals to 0. 3 plus b is equals to 0. B is equals to, you take this 3 and put it to the other side, becomes a minus. So we have b now. Let's find c. A plus b plus c is equals to 0. A plus b plus c is equals to 0. A is 1. B is minus 3 plus c is equals to 0. 1 minus 3, we have a minus 2 plus c equals to 0. Let's take this minus 2 to the other side to change its sign. It becomes positive. So we have c is equal to 2. So what's left is we have to substitute into this n squared plus bn plus c. So our general term is a is 1. What's b? B is a minus 3. So a is 1, b is a minus 3, and c is a plus 2. So this is our final answer. Tn is equals to n squared minus 3n plus 2. Now let's recap how you find equations for a geometric sequence. Given the following sequence 2, 4, 8, 16, determine the 14th term of the pattern. Use the formula. Let us write our pattern first. 2, 4, 8, and 16. Let's find the constant ratio first. That's the first step. Always find the constant ratio. 4 divided by 2, you get a 2. 8 divided by 4, you get a 2. 16 divided by 8, you get a 2. So r is equals to 2. The first term, a, is also equal to 2. Now the formula Tn is equals to AR to the power n minus 1. Let's substitute Tn is equals to A is 2. 2 times R is 2. 2 to the power n minus 1. This is the general formula or the nth term for this number pattern. We use this to find any term in this number pattern. Now, lastly, they asked us to determine the 14th term. So T14 is the 14th term. You substitute n and you put 14 there. This is equal to 2 times 2 to the power 14 minus 1. This is the same as 2 times 2 to the power 13 or 2 to the power 14 when you add 1 plus 13. Let's punch that into our calculator. You find it 16,384. That's the 14th term. So this is our last example. given the geometric sequence 30, 10, 10 over 3. Let us see how you can determine the equation. So let's start. 10 divided by 30, you get a third. 10 over 3 divided by 10, 10 and 10 will cancel. That's also a third. So our constant ratio is a third. A, the first term, is 30. So Tn is equals to AR to the power n minus 1. We substitute. Tn equals to A is 30 times R is a third to the power n minus 1. This is the general formula for finding any term in this number pattern. Now, we want to find the n on this value. So, this fraction is our Tn. We want to find the n to see which position in the sequence is this fraction found. Okay, so we are already given Tn. It's 10 over 729 is equals to 30 times 1/3 to the power n over minus 1. Let's divide by 30 both sides. 10 over 729 divided by 30. This side you are only left with 1/3 n to the power minus 1. This you on the calculator to simplify to 1 over 2187. Now let's simplify here. This is the same as 3 to the power minus 1 times n minus 1. Let's simplify the right hand side. 3 to the power minus 1 times n is minus n. Minus 1 times minus 1 is a plus 1. Okay, so this will simplify to 3 to the power minus n times 3 to the power 1 according to the laws of indice. So we have a 3 here. Let's divide both sides by 3. 1 over 2187 divided by 3, you get 6561. It's equals to 3 to the power minus n. So this looks like this, 6561, 1 over 3 to the power n. So what do? Let's multiply everything throughout by the common denominator. The common denominator is 3 to the power n times 6561. So this times these two will cancel and you'll be left with 6561. This times this, 65 and 65 cancel, you'll be left with 3 to the power n. So 3 to the power n equals to, you can find this. You can use the prime factors. 65, 61, you can use 3 to find how many times it gets into that. It will get 3 to the power 8. So if the bases are the same, the powers are the same, n is equals to 8. So our final answer is 10 over 729 is equals to T8. So that's it for now. We were recapping how to find the nth term. In general, you were looking for an equation which governs the sequence. Then we use that equation to determine the position of other terms. Or if you are given a position, you will be finding the term in that position. So that's it for now.